Orko telling or Prajota telling? Who is
Yes, sir,
telling?
Orko.
Okay, Prajota, then unmute your microphone. Okay. I think Prajota's microphone disturbing today. Okay, no issue. Is it okay, Prajota, now?
Sir. Yes, sir.
Now just uh, mute your microphone, so I think noise will not come. So I think in your view, whatever you are saying that in case of embedded system, so it is just a computing system, computing devices embedded.
Yes.
Orko,
Yes, sir.
if you are saying that it's just a computer system embedded, then what is the difference between computers and embedded system? Any differences? Somnath?
Embedded systems are mainly for specific tasks.
Embedded system in
They perform their own specific tasks.
that is a very important point for specific task. Good important point. Who's the fellow Rohit?
Yes, sir.
Yeah, very good answer. It is one good point I found that it is specific task oriented. Okay. So Orko,
Also it can work either as an independent system or as a part of a large system, which is not possible in simple computers. Like
it is
simple.
generally embedded systems, say the word means embedded within the large system. So generally embedded system works as a part of the large system, though it is not controlling all the devices of the large system. It may be part of the system is called individually embedded system you would like to work. So what is the application? Can we give some example? The individual says individually it can work. Any idea?
The biometric detector.
Remote,
Yeah.
remote controlling or
The microprocessors.
washing machine, microwave.
The biometric detectors, sir.
Not clear. Am my whiteboard is visible to all of you?
Yes,
Yes,
sir.
sir.
Okay. So if the first class in this matter that in this I would like to highlight that what actually embedded system we would like to mean. If in a large system particularly the thickness should be high. Suppose this is the large system. Okay. In the large system, you can tell there's a embedded system. Is it visible to you? Embedded. I can say it is a large system and inside a part is embedded. So large system can have multiple applications. I don't know, numerous applications are there. And all these applications, I think not be controlled by the embedded. Maybe some application. Are you getting my point? Not all. Be careful. Not all application or event are that means control. Are controlled by yes. I am writing embedded system means yes. Okay. From now onwards, you try to understand yes means embedded system. So all may not be applicable. Then the portion, whatever I am mentioning here, you can say this is the sphere of control. I can say you can see the sphere of control of yes. Did you get this point? Sphere of control. Are you getting my point or not? This is the very important thing you have to understand. Otherwise, you always get confused that what is the actual embedded system. In last class also I told that the larger system, or you can say environment. Larger system or environment, it gives the input to the it gives input. Actually, embedded system takes input from the larger system and process the output. During this event trigger, I already mentioned that everything cannot be sensed or actuated by the embedded system. So there is a sphere of control. I am just focusing those sphere of the control. Main problem is that there might be a sphere of control in the larger system which might be controlled by the embedded system. So our main task as a best example is that, did you heard the term autopilot?
Yes, sir.
Yes,
Autopilot.
sir.
I know in the aviation system, autopilot is very sensitive things, and mostly you can say except the landing and takeoff, or in some exceptional rough weather, or maybe some terrible odd situation, mostly all the trucks controlled by the autopilot. It is, I have seen also mostly international flight, when you are going the longer distance, you feel that the pilot also coming from the cockpit and moving with you, storytelling that how the car flight is moving. So lot of application, maybe weather sensing, maybe temperature sensing, maybe directional sensing. That means I am telling the latitude or longitude, whatever maybe. All these are controlled by the different controller. And all these automatically are controlled by the embedded system. But it may happen sometimes other activity. That means like in this sometimes uh, if nowadays the camera is evolved, camera is there in the inside outside the that means in the passenger portion in the corridor, if some camera is there, and if some that means passengers feeling some uneasy situation or maybe sickness, so automatically medication can take place. But that is the task of the image processing, because pilot will see and can be done by the other person, but it cannot be done by the embedded system. So a lot of events are there also in the flight or aviation system which cannot be controlled by the embedded system. Am I getting a point or not? But the distance, longitude, latitude, the temperature sensing, all these things can be automatically detected by the embedded system. So that is the very important point. I am telling that sphere of control, which are all controlled by the embedded system, that is the very important point. Is clear these things? Now automatically you will find that I told that mostly the whatever we are interact with the outsides are analog. Am I correct? Analog. Most inputs in the sensing data, whatever coming out are analog. Then how our embedded system will process it?
So
By
they
converting it into
of
3D.
analog signals into digital signals.
Digital, digital means
So as in discrete signals, using a processing micro controller, and then like it first modulates, then it passes through a processing microcontroller processor, and then again converts from digital to analog, and makes it go through an actuator, and if necessary other systems, and finally back into the sensor, sir.
okay. This is our embedded system, and there is the I am writing sensor. Clear? Sensor give the signals, and this is coming to the actuator. Okay. And actuator may impact, I am telling the other system, or you can say it is the a part of a large system. Already I mentioned all the part not be controlled by the embedded devices. So this is the part of the large system. So now this controlled by this one. This is again sense. This is the environment you can say. So this is our one of the environment. Now my question is that this is mostly analog. Mostly analog. Also, whenever you're delivering to the output, that is mostly analog. Okay. Now our digital system, which is embedded within the itself, that means larger system part, embedded system how will process. So you are advising that I have to give some here, some converter. Are you telling this one or not? I
So
have to add one some converter. Clear? And that I am writing analog to digital converter. Same way I have to apply, there is a digital to analog converter. Am I correct?
yes, sir.
Yes, sir.
So if you notice this clearly, I can say These are my input unit processor. If I go for our previous or architecture class, can I say this is my output part and this is my processing unit?
Yes,
Can I
sir.
say? So it is like a
Yes, sir.
computer. So it is like our modern computer. I can say or not. Modern computer, that means general purpose system. I can say general purpose, multi-purpose system. Can I say or not? See, it is a some input, it is some output. Okay.
But it is not for general purpose.
Now, so one thing that, but I am telling that like our computer, it have the same feature. It is true or false, tell me. Input, one part input, number two is output, input output, so whatever maybe. Number two processing unit and their communication interfaces also, they are like in this way. So my question is that even these three features are there. Just an important call is coming, wait 1 minute. Arthur, I'm in class. Can I talk you later? Hello, I'm in the class. So if I compare the GPS, I can the general purpose system versus now I'm comparing embedded system. Is it clear? So I can say fast task, whatever Rohit had already mentioned, that is single purpose application. Am I correct this one? Single purpose application. Can I say it? Okay. So this is the very important. You must remember embedded system are mostly, you can say mostly, oh, the phone is continuous coming. Hello, আমি তো ক্লাসে আছি, ক্লাসটা শেষ করে ফোন করি। Okay. So embedded system are mostly I can say single tasks, mostly single, but sometimes heavy, maybe two or three, but tasks oriented. Can I say? Task oriented, and once it's developed, it will perform only these desired tasks. Except this you can't do. Whatever we can do, suppose you purchase a general purpose system like our microcomputers. What happened that you can play with games, you play games, you play audio files or video files, you can do official works also. Lot of things you can do with your general purpose, but in this cases it is single purpose. So we can also mention that this is predefined. The tasks, whatever the purpose, it is predefined. Is it clear? That is the very important thing, which is completely separate. That means different from our general purpose. Be careful during study of the embedded system. The purpose of the embedded system should be clear to your mind that what is the actual purpose of this. Now it is clear, I think. Second is some constraints. Very important points for embedded systems are constraints. What are the constraints? I can say, you can say tightly. No, tightly coupled and loosely coupled. Can you say anyone what is the difference between tightly coupled and loosely coupled environment?
Sir, as in any changes will have like instant repercussions on the environment.
No, I am telling that tightly coupled system or loosely coupled system. Suppose I have a memory, processors, uh, uh, shared memory and integrated memory. Such type of concepts are there in our computer architecture. If each processors are embedded with some its own unshared memory, that time I can say this is tightly coupled. That means processor and memory are tightly coupled within themselves. But sometimes multiple processor sorry, can share a single shared memory. Are you getting my point? So that time you will get the difference of, I think, loosely coupled scenario. Are you getting my point?
Sir, could you repeat, sir?
I am telling that the system, suppose this is the processor, this is a processor, this is a processor core, and there is a shared memory. Each of them are sharing this one. Okay. Even they have some own individual memory also. But if for their data contents also, if they depends on this memory, that means I am telling that these are all dependent on the output of the shared memory. So I can say tightly coupled scenario. Okay. But if they don't depend on the shared memory, their own individual copies are there and they can operate on between them and no dependency is in there. So all the processor can work independently also. That time I can say that is loosely coupled. Are you getting my point or not? Tightly coupled means that they are dependent each other. Maybe multiple processors are there, but they are dependent each other in terms of memory. Just I given the example memory, but may not be memory. Other things can be there. So loosely coupled environment, you will find mostly the scenario in this. Now, what all of you are doing, I don't know. But if you come in the class, physically class, in the class, if someone is sleeping and someone singing or someone doing playing, I can immediately interact with him. Is it possible or not? The classes scenario, whatever in the physical class is tightly coupled. You can't do anything without my permission provision. But what you are doing, I don't know. Generally, you people are maybe sleeping or doing something else. After joining, possible or not? There is a possibility? Possibility or not? Bah, that time no answer.
No, sir.
Yes, sir. Yes, sir.
Possibility is there. I am not telling that you are doing, but I am telling that there is a possibility. So in these cases, that scenario is loosely coupled scenario, but independent dependency is very less in loosely coupled scenario, but in tightly coupled, dependency is tightly coupled. Now I am telling the constants are tightly. That means this should be there, must be there like constant. Like what feature? Low cost. Very important feature. Low cost. Our general purpose system, since it solves the multiple purpose, so it may be low cost, may not be low cost. But generally, our that one embedded systems will low cost. Otherwise, it will not be affordable by the client because it is a task specific, predefined task it will follow. Suppose a printer, it will only print. I'm not telling about the multi-purpose printer, print, scan, copy. I'm not doing. It is only for print. So if the cost of the printer is more than the CPU or sorry, more than the processor or more than the other printing devices like a handwriting of also I am telling, if the cost of the printer is so high that we can't afford, then what is the purpose of this designing the printer? Its cost should be reduced so that we can afford it. Nowadays it may happen the laser printer cost is coming 15,000 and the XZ printer is coming 3,000. You can afford it also, the XZ printer also, but printing purpose can be solved with the low cost purpose also. True or false? In your
Yes, sir.
home, do you have a printer? Any one student in your home, do you have a printer?
Yes, sir.
I think printer. Which type of printer? Laser or DexZ?
Sir, there's that.
DexZ. Why?
Economical.
Economical. If the cost of the DexZ and the LaserJet is same, then which will be purchased by you? LaserJet
Then
automatically.
maybe laser jet. Yes, sir.
That's why LaserJet companies are trying to go to the reducing the price as much as possible. Earlier days when I was in my like you college student, I found that cost of the laser printer was 50,000 minimum, and that was the minimal features. Now that is coming near about 15,000. So this is the reduction. Now after maybe 10 years, it can be 3,000 and 4,000. Then everyone can afford the laser printer. True or false? So low cost is the main important feature in the embedded system which cannot be general purpose system. Second is the low power, very important feature. Here I am telling low power, but in your most of the lecture you find power hour design. That means our embedded system always should consume less power. That is a very important feature because mostly I can say most of the various application you will find embedded system which is battery driven, or if the power consumption is be high and battery drained out. Suppose you cell phone, the best example. Cell phone have lot of embedded applications and embedded features also there. Now, in the cell phone, it is a very large system. In the large system, there is a processors, there is a controller. So in the our cell phone, which is a large system, it has embedded system application or embedded system also within itself. And that embedded system, if takes huge power, particularly I found earlier days, whenever you on Bluetooth, you have not seen, I have seen that one, that is 2002 or 2003, automatically the drained out the entire system. So always by knowingly or unknowingly, we try to stop the Bluetooth. Are you getting my point or not? Nowadays, if you enable the Bluetooth, I think this scenario will not come, at least. So I have to design the embedded system in such a way that it must take, it must consume less power. So that is the very important feature which in the general purpose system we think about is flexibility. Never think of this matter. Though we try to do, but generally we go to the tasks. What are the different tasks it will perform? Like if you have some GPU based computer, you will understand that huge power consumption takes place in the laptop. If it is GPU based computer comparing the normal. So in embedded application, you must remember that it should be power efficient, or you can say low power. Second most important is the portability. It should be portable. Are you getting my point? Easily carry a hand up that I can carry easily from here to here. So this is the very important features of the embedded system, that it should be portable. Easily we can drive from anywhere here to here. Second point is that another very important point is that sometimes, I am not telling most of the time, sometime it should work in real time scenario. I will explain now what does actually means real time. Any idea of the real time?
Sir, means very less delay. The operations happen with very less delay, like in a missile guiding system, very less delay.
Okay, so one point I am telling, very less delay. I think he is telling that computing speed, computing time should be less, na? You are telling this one or not?
Yes, sir.
Or we can say another term is less. We also call latency also, but I am not telling latency because latency have some separate meaning. I will come later. So very computing time should be taken by the system. Okay, that is the very any other point. What is I am telling the real time? See, because if you don't clear this point, you can't design the system.
So
Okay,
if
real time.
applications are running inside itself, they should be like dynamic in nature, as an update
Mm.
along with changing conditions.
But you are not going to the basic feature. Why it is real time? Real time system, that the system works in real time. Can I say or not? Can I say this or not? System works or should work, or you can say must work on. Why should and must I will explain later. Just tell me must work on real time. Real time means in my hand there is a clock. I will finish my classes 12. I will start my classes 12:10. I will go to my lunch 12:30. Like in this way, at specific time I will do the specific tasks. So that is the real time I will apply. Getting my point or not? So system should work on real time. And my point is that I am telling that embedded system may sometimes may not also. So all the embedded should system should work on real time. That is not true. But a real time system can be embedded system. That is true. Is it clear this point? All the embedded system should be a real time system. That is not the true. It can be, cannot be. But a real time system can be a embedded system. True or false? If I say all real-time systems are embedded, is this true?
No, sir.
No, sir, because there might be a delay also.
Also, all real-times are embedded system. That is also false. Again, all embedded system are RTS system, that is also false. So there is a correlation between the real-time system. I am telling that the system which works on real-time. Best example, you take a railway reservation system. Okay, I am taking a railway reservation system. So Bonali is there.
Yes, sir.
So it is question to you. You just tell me in railway reservation system, you will find that mostly, I generally we find that when you booking a ticket, the system
Yes.
works in real time or not? Is the system works in real time or not? What is your understanding?
Yes, sir. It should be.
It should be or might be.
So availability is based on real time, so it should
Yeah,
be.
availability. So you are checking that when I going to book a seat in my train, so seat should be available
Yes, sir.
during that period, during that time when I'm booking. If it is not available, so seat cannot be booking. So it should be real time. Otherwise, a single seat can be booked by multiple person. That is a very dangerous ambiguity. Am I true or false? So the booking system in railway particularly should work on real time. Otherwise, a catastrophe effect will happen. That when you are coming to the compartment, you will find that your seat is already occupied by the others. So then fighting will happen. Same thing in a real time system, it should work with the real time environment or real time event. Now, if it is a real time, suppose I am considering those embedded system which is RTS, the real time system. So it can be a hard real time, clear, or it can be a soft real time, clear. In hard real time, it is a time constant. It's a stringent time constant. Remember this point. If you are working in a and that means real-time system, you remember that if it is a hard, be careful. It is stringent time constant. It means that suppose that means if you miss the deadline or if you miss the time, a catastrophe will happen. Are you getting my point or not? A catastrophic scenario will appear if you miss the deadline or time. That in violation time can lead a catastrophic event. Can I see this? Can I say this? Violation of the time can. I am not telling may. It is can. Be careful. Can lead catastrophe effect. Is it clear this point? Best example. Suppose boiler. In an industry, it is given that when boiler will reach X degree temperature, then automatically power should be off and a coolant should be there. Particularly this type of boiler or you can say ignition chamber in nuclear. Dangerous thing, na? You found whenever nuclear calamity happen, huge water is giving the nuclear furnace to minimize the heat. Otherwise, an explosion can appear. True or false? So you know whenever this temperature will reach, automatically switch on the system and coolant should be there. If it is not happen, what will happen? If it's a nuclear, understand this thing. So these things are hard real time. Again, another example is that aviation system. If a flight is landing or maybe takeoff, during the landing it is there within the 2 minutes. If it is never land within the distance, then there will be a massacre. So these all these application which controls the such sphere of control by the embedded system, we can say hard real-time system. Is it clear? Now in soft real-time system, if there is a violation of the, you can say, that means time, may lead poor quality of service, but no such huge catastrophe will happen. Am I getting this point? Quality of service or the tasks may be degraded. Are you getting my point? What is soft real time and what is hard real time? Any doubts? Suppose one example in the soft quality, uh, your camera. You are capturing a camera, you are capturing movies or maybe picture with the camera. Initially the camera was very faster, but day by day it's become slower. So what will happen that it happens or not in mobile? I think it happened, na?
Yes, sir. Yes.
This is the effect of aging. Generally, it happen in the CMOS or silicon devices. After 3 to 4 years, you will find that your mobile, whatever working earlier, the speed it is little bit degraded. It happens. The quality of the service, the speed is degraded, but the service still is done by that. No catastrophe will happen. Are you getting my point? So these are the best examples of the soft real-time system. So I think if anyone say you are working on hard real-time, so be careful about the model. So what does it actually mean? That the deadline, whatever you specified for the system, your system you should design like in this way that it never fail the deadline or timing. Otherwise, it's a big problem. Particularly if you are working in aviation system, nuclear furnace or boiler like this is or any chemical industry. These are the mostly you will find that real-time embedded systems are there. But as well as in case of our computer systems or printing devices or scanner devices, maybe you will find some soft uh, real-time system. Is it clear? Is it
Yes, sir.
clear or not? Okay. Another
Yes, sir.
very important features you will find that our embedded system we already classified maybe hard real-time system or maybe soft real-time system. Embedded system if it is RTS. If it is RTS. Now another features of the embedded system you will find that you will get there is embedded system, maybe you will find a reactive system or it may be transformational system. Okay, transformational system. Any idea? Can you explain what is reactive and embedded system? Suppose you have some digital camera. You have some shutter button. Okay.
Causal system, sir.
Yes.
Sir, reactive system is a causal system, sir.
Can you explain a little bit?
Sir, in case of causal signals, sir, if the time is shifted of the input, then the time is also shifted of the output by equal measure. So
No,
in
no, 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 no. I am not telling this one. Reactive system, high, little bit, but generally it is not. I am telling that it is shifted, then it is shifted. That is the also reaction. Yes, good. It is reflect a response to the changes. That also partially reactive. But I am telling reactive best example is that the system which reacts with the event immediately with minimum latencies. Minimum latency. The transitional time or the reaction time will be comparatively very less. Sometimes we can say our friend, you are very overreactive. We can say or not. With any circumstances, sometimes you tell or not him, you are very overreactive. It means that what? He reacts instantly and in a large scale that is overreactive. But if I can say you are reactive, that means you respond immediately with the event. Am I correct or wrong? So when you press the shutter button of the camera, automatically it captured the image instantly. So I can say this controller for shutter and capturing the button is reactive embedded. or you can say reactive system. Can I say this? So shutter of the digital camera is the best example of the reactive system. Every time when the event is triggered, automatically it reacts to the event. Am I correct or wrong? Am I correct or wrong? This thing. So this is
Yes,
the
sir.
best example of the reactive system. Your friend is overreactive, not reactive system. Don't consider the other. But now in transformational system, I am telling, suppose you are capturing an image will be modified or processed, then it will be stored in your SD card. It happen. So little bit timestamps delays are there, but it may not be visible to you due to the parallel or pipelining processing. That there another issue. But it happened that you will find some processors are there for image processing devices. So processing unit is the very important part. In my image slide, I will show you that what is image processing side. Today I am discussing all these things, but when I will discuss a digital camera as an example system or embedded system, you will find that there is a transformational unit. That means some processing units are there. So there will be some processing unit, maybe some JPEG codec, maybe some any other codec or compression techniques, or after that brightness, contrast, anything you can change it, and automatically the system will change. Maybe it can be software system, it can be hardware system. Be careful. It can be software, it can be hardware. Possible or not? JPEG can be implemented in hardware. JPEG compression can be implemented in software also. That also, as per the demand of the market, we can modify. But again, there is a processing. That's why I'm telling transformation can be software, can be hardware, but it's has some computing delay. Is it clear this point to all of you?
Yes, sir.
Okay. Try to understand this term will come every time during the discussion of the classes, and that time you don't say sorry what is the reactive system. So real-time system we understood, it's works in real-time environment as per the clock of our or watch time of our environment or our clock. In real time can be hard and soft. Again we found in the environment also it can be reactive and transformational. Mostly reactive systems are instantly working and there is a less processing delay or less processing tasks may be there. Now, why I am telling that this is the very important thing, because in embedded systems, especially you will find one constant, that is one is hardware constraints and another is the software constraints. Very important thing. Why I'm telling? Very important because now JPEG coder, already I mentioned JPEG coder, which can be implemented with the hardware directly. And also JPEG coder is implemented with the software also. Possible or not possible? Possible or not possible?
Sir,
Yes,
repeat
sir.
the question, sir, once.
I am telling that in a hardware constraint and software constraint, these two have very high impact on embedded system. During the designing, you have to think about the hardware as well as the software. Now, if you think about the hardware part, in the hardware part, I am telling that JPEG coder I can implement in the hardware, and also JPEG can be implemented in the software part also. I am asking that whether it is possible or not. JPEG possible or not? Hardware software both.
Sir, not sure, but since you are saying it must be.
Okay, I am telling that in digital camera, you will find that when camera capturing the picture, I'll show the slide. You will find a JPEG coder. Is a hardware. If we make it hardware, automatically the system will be fast. It will fast or not? You don't know
Yes, sir.
hardware control unit and microprogram control unit. Forgot. Or Tishman, are you there in the class?
Yes, sir.
Which one is faster, hardware control unit or microprogram control unit?
Hardware control.
Why?
Sir, in
What would you say? Software needs some programming or algorithm to follow and process. The resource should be not dependent. I have to find the resource independency and then I have to fetch the data. All these things, so many things are there.
yes, sir.
So hardware system always fast, specific hardware for specific task. Now, in case of programmer oriented, what is the advantage? Which is not possible in the hardware?
So we cannot reprogram it.
Reprogram, the flexibility issue again.
Yes.
On the flexibility in case of control unit, or also we can say in the digital camera, if I delete the hardware part of the JPEG controller, I think the size of the product will be less.
Yes, sir.
That is very important in our embedded system. So JPEG can be hardware or software, that is requirement. So we have to, that means increase your space or size. This hardware, though it is fast, but it can increase the size or cost of the product. True or false? It is fast, but size and cost can be increased. It is little bit slow, but size and cost will be very less. Am I correct? So there should be a trade-off between the hardware and software. When I'll show the slide, you will try to understand what I am meaning, that there should be trade-off between hardware and software. Is it clear? Now this point, why I have to maintain the trade-off? Because to maintain one dimensional speed as well as the size and cost of the system. So both the design, that means hardware based design or software, is to be evaluated simultaneously to make a trade-off. This is the vital parameter in designing the embedded system. Is it clear? You have to evaluate. If I make a hardware based, then what will the benefit? If I make software made, what will the benefit? And then compare that how much I have to make hardware, how much I have to make software for a particular embedded system, that the product cost will be low and portable. That means these are the all features what I mentioned already maintained. One of the best physical best example today is CPS. Did you heard it? Did you heard it? Cyber physical system. Hard or not?
No, sir.
Anyone? Cyber physical system, have you heard or not? Can you
No,
explain?
sir. No, sir.
Never heard, na? So cyber means we are telling that computing environment or computing scenario, I'm telling cyber based. Okay. And physical is the real or physical world. Physical world and then system. Most suitable another example of the yes is now CPS also there. That means cyber physical system. And nowadays this entire CPS also controlled by the another feature that is called IoT. That you know?
Yes, sir.
Yes, sir. Yes.
IoT, Internet of
Internet
Things.
of Things.
Yeah. Now my example, there is the another features that is embedded. But before that, you should understand what is CPS. IoT is a good application on CPS, but if I don't know what is CPS, then purpose is not solved. Now, best example that suppose you can say car without driver, or you can say driverless car. Okay. Now it is controlled by the maybe IoT, another example. So it is decided that from destination A to destination B, it should reach 1 hour. Maybe oxygen cylinder it is carrying, maybe some medicine it is carrying in the COVID pandemic. So it should be reach there 1 hour. Now, in the source A and B, there may be some road conditions or undulations are there. Some rough patches roads are there, some smooth, and maybe somewhere some high orientations are there. Okay. So in this scenario, I am telling that in this scenario, now the speed of the car is controlled by the U. Speed of the car is completely controlled by U. When car is moving towards the direction, when it will come in the rough edge way, automatically due to the friction with tire, the speed will increase or decrease?
Decrease.
Decrease.
Decrease. So what we have to do? By remotely, we have to increase the speed of the car to maintain the speed X. Am I correct? Speed.
Yes, sir.
Again, when in the small places, speed will
We need to
exceed
decrease the speed.
X, we have to decrease. Again, when you go high altitude, we have to increase, maybe first gear, second gear, whatever maybe. So like in this way, as per the frictional part which comes contact with directly with the tires, which reduces the speed of the car. True or false? That means the physical environment directly interact with my system. Is it interacting or not?
Yes, sir.
So that physical interaction which is coming to directly with my system, and now I am controlling with my cyber application. So this is the one best example of cyber physical system. Now it's controlled by the remotely, by the IoT's application. So earlier the controller should be within the car itself, so that as per the friction of the tire, the controller increasing the speed or decreasing the speed. Okay, to maintain the standard speed 40 kilometer per hour, suppose, and distance is 40 kilometer. There is no traffic. Forget about this traffic part. So in this scenario, nowadays that controller which was embedded the system now remotely can be done by IoT, but same thing, a computing device, that is my cyber part, which I am controlling by programming or remotely by programming or remotely from wireless acquisition. And now it is converted in the physical. So the CPS is the another application of embedded system. Can I say or not? So cyber physical system has a lot of application of embedded because the speed is controlled. So there is a controller which takes the input from the frictional tire, which is accomplished by the physical friction. All these things will that means propel to design the system accordingly. Understood the point? So the last on the end of the lectures we are coming, then what are the challenges we are facing during the development of embedded system? So first embedded is the NRE cost. NRE cost means, can you tell me what is NRE? Anyone? Non-recurring engineering cost. That means the cost incurred during the development of the product. That is the very important, that your design should be in such a way that though your design, my design, both are performing the same task. System developed by A, system developed by B. Both are perform the same task, but it may happen that cost of the product is high comparing me. But it happened that once the cost was developed, once particular one cost, the design you have done in such a way that the cost is once X and my was X minus 1. But every day my cost is X minus 1. Every day my cost is X minus 1. Every module when I develop is cost action. But in your cases, it may be X once, but after that, whenever you will go, it is X minus 1, X minus 2, X minus 3, like you, the cost can be reduced. So the development code to product to develop a product initially, the total cost incurred by the management or the developer, that I can say the our non-recurring cost for the developer. Recurring cost, that the daily expenses is whatever we incur, daily expenses, that is whatever we incur the recurring cost. Non-recurring cost during the one time when you develop the product initially, the cost should be very less. So that is the very important in defining the embedded system. Comparing general purpose, embedded system non-recurring cost should be less, but generally, if you compare the each tax, it is very high because embedded system cost is 10K. Suppose a general purpose computer cost is 25K. But by seeing from outside, I'm telling the NRE cost 25K is very high, 10K is very less. But see, in within 25K, you can perform 10 tasks at least, but it is mostly 1 to 2 tasks. So corresponding to the tax in regarding the tax view, the cost of embedded system always high. But comparing, that means NRE cost is high comparing GPA because multiple tasks it is done by the same system. So initially cost would be very high for GPS, but due to the flexibility, it will be very reduced. But the NRE cost for the embedded system mostly high. So you should try to develop the system in such a way that as much as possible, the NRE cost can be reduced. Is it clear? So very important during the designing of the embedded system because NRE cost is always the brainstorming situation in our cases. Then again, size LRAL tool, since mostly it works is a part of the largely system. So our motivation should, it should as much as less space in the disk should be occupied by it. That is the size. Okay, already I told that if the few hardware can be converted implemented by the software, we will go for that one to space or the size of the device will be very less, so it can be easily portable by our hand, pockets or bags anywhere. So always we favor it more. If the mobile size is like a tab size, not our handy, so it will be very difficult to manage. Second option is that I told that power, I already mentioned that it should be power efficient. Four is the flexibility because it is less flexible, but we have to improve the flexibility in such a way that suppose I have a device of the mobile phone which have support 4G, 5G, and you have a mobile device which have a 5G. Which one is more preferred? Which one is more
4G,
preferred?
4G, 5G.
Because the flexibility. Because the flexibility. As minimum as at least try to provide the flexibility to the embedded system, which should be as per the reaction of the environment. So flexibility is the another issue. And the last, not the least, that I am telling performance. That is the very, very important thing because since it's a task oriented, so it is very important and the performance are measured in case of embedded system. One is the latency, one is the throughput. Now try to understand latency and throughput. Suppose a system A latency is 25 seconds and system B's latency is also 0.25 seconds. Okay. And I am telling that the camera, suppose it is a camera, digital camera, system A camera taking 4 clips per second and it is taking 8 clips per second. But the latency is always same. Which has the maximum throughput?
B.
And 8
B.
clips.
B or A?
B.
B,
B. Why? Is it possible? With same latency it is possible? See, system A first take the picture. Okay, then picture is processed, then codec is applied, then it is stored in the SD card, then again start the next picture. This is the system A. System B capture the picture. When it is started coding, it taking the second picture. When it is given to the processing, it take the coding. So a pipelining or you can say multi-threading environment is applicable in this one. So having same latency, throughput differences. So that's also the main thing of the design criteria. If you maintain this design criteria, the performance of the embedded system will be boosted having the same latency also. in the same clock cycles, you can get multiple tasks, possible or not. So that way the performance, so just always don't say my clock cycles is very high than you, so my computer is very fast. I can't say. I have to think about the throughput. Maybe your speed, maybe your system is very high clock speed, but you are using sequential tasks, and my system has less speed, but it is doing pipelining or threading and multi-threading environment, which will be better, will give better throughput. Automatically, those systems with them the multi-threading applications are running parallel. So that's why always better clock speed does not mean the latency is high, then automatically latency is very less. That means high speed environment always assured the maximum throughput may not be happen. I think that I discussed in our COA class also. True or false? Am I clear?
Yes, sir.
Yes, sir.
Okay. Another very important point, that is the most companies say the management angle, that is time to reach to the market. Time to reach to the market. This is a clever that develop the prototype. That means as fast as you can develop the prototype. Don't make any noise in my classes. Otherwise, I will not allow you to enter my classes for next 1 week. I know the time. Don't make any noise. This is the children's play. That class is timing, so we start disturbing the teacher. So time to reach to the market, then develop the prototype. That is a very important features. Another features is that, see, most of the questions in the examinations which come from my discussion. It is in the books, mostly not find. So that's why try to understand the lectures. So maintainability, that is the another very important features. Time to reach as well as the upgradations or updation option, or maybe sometime some new feature can be embedded with some changes little bit. So automatically that all these things will boosted the designing of the our prototype. So that is the another very important point. So nowadays, whatever we understood that embedded system very critical is task specific, or is you can say predefined tasks. Am I correct? This is a very important thing. Second is that challenges as per the tax cost, very important parameter. Cost, it may be mostly NRE cost should be less. The another important challenges. Another is that size. Size, that is the very important parameter. Power, then flexibility, and finally we can say performance along with the time to read. So these are the all important feature which will enable to design an embedded system properly. Is it clear? So it is not that you make a system which is not affordable, also not suitable. Also you make it so compact to make it the most compact, you compromise with the performance. That is not be acceptable. So there should be a proper trade-off between this. So this slide I will upload in Moodle today for your revision. Okay. So mostly we will meet on Friday 4 to 5, but Thursday try to check my notices the night particularly. It may happen that Friday 11 to 12, if there is some meeting generally Friday, a lot of tasks takes place the weekend. So these classes may be postponed to 12 to 1 also on Friday instead of 4 to 5. Okay. Is it audible to all of you?
Yes, sir.
Yes,
Yes,
Okay.
sir.
sir.
So at least Thursday, all of you must check that notification that classes can be shifted anyhow anytime. Clear?
Sir,
Okay.
Tuesday, sir. Tuesday, sir.